Benjamin at Work, Episode 6. You can learn stuff here.
Welcome to episode 6, Benjamin at Work. This week I'm going into teacher mode because of the things that we have been dealing with about numerical issues. I didn't want to leave any of the details out, and especially because of the fact that we're dealing with computer problems. And when computer problems are in the house, I tend to lose myself in them. So we're going to start out talking about number precision in Excel and a few other things, because we're sticking with Excel problem and the ellipse problem. This week's old business is also this week's new business.
Going back to the numerical precision problem that was found in Excel in the previous episode. It turns out that this problem was not unique to this project, but it is something that is a frequently encountered issue with users of Excel. I found a document on the internet in the Microsoft document library that discusses this particular problem. In fact, there were several documents of this same type, and some of them also gave tips about what you can do to correct or avoid the errors that are inherent in the Excel software. I'm going to summarize those things that were discovered while reading this document. One of them is that Excel is built its numerical processing on a IEEE standard called the IEEE 754 standard for binary floating point arithmetic. And within this standard, it was stated that there are some numerical errors that are unavoidable because of the nature of the translation of decimal numbers into binary numbers. There are certain points within these number systems where absolute accuracy in the translation is not possible. However, Excel dealt with this problem in versions past Excel 95, and in particular the problem that we were having near zero was supposed to have been corrected by Excel in all versions later than Excel 95. So that leads me to conclude that the free online version in Office that I had been using to do these calculations may be a pre-Excel 95 version. And if we want to get better accuracy, we may have to get a premium or more recent version.
Since I drew a blank on new mutual force ideas, let's go ahead and have some more ellipse talk.
Referring back to our list of equations for the formula for the ellipse here, while ruminating over the form of number 4 on this list, I considered this as the equation that best represented the combination of two circles to create an ellipse. Well, this equation actually has a very, very obvious relationship to the circle formula. And while tossing around different substitutions that I could make into this equation, I came upon the substitution of pi. And when I looked into the right-hand side of the equation where I would get pi AB, that immediately said, hey, this is the area of an ellipse. And so on the right hand side with pi in there, it would be the area squared. This suggested the question to me, what if the area contained in the boundary of an ellipse is related to the magnitude of that boundary or the perimeter around that area? So I added this method of finding a equation for the ellipse that has a closed form perimeter solution to the list of uh, approaches that I should take in pursuing that goal.
The difference between the meaning of formula and equation and how those two words are used.
As nouns, the difference between formula and equation is that formula is any mathematical rule expressed symbolically, while equation is an assertion that two expressions are equal, expressed by writing the two expressions separated by an equal sign, from which one is to determine a particular quantity. That definition comes from Wikidiff on the internet. We are going to wax philosophical here and recall that in the past episodes, when I was discussing all of these equations, I made the statement they are all the same equation. And then I began to think about that and say, well, they are in one sense the same equation, but then in another sense they are not because they have different things on the opposite sides of the equal sign. And I felt that it would be more correct to have said they are all the same formula for the ellipse, containing the same elements or components, but they are expressed as different equations, having different things or different elements on the opposite sides of the equal sign. So it would be interesting to find out what you think about that. What is your opinion or idea about what is an equation and what is a formula?
And now I'm going to introduce you to the new method of computation that I'm going to put into use, an open source package called Octave.
In order to find out if my computer was responsible for the numerical errors that was resulting in the hardware sense, I used another program called Octave to reproduce the tables that I made in Excel. Octave is an open source program used by scientists and engineers that has a MATLAB-like character and a high degree of compatibility with MATLAB. So here you see that I have created the x values as a range from 0 to 2 in the same steps, size as I did in Excel, and then I reproduced the y equation for the ellipse and generated that column of values, and in this case it's a row. And when I got to the 0, there was no problem there. So that reassured me that the hardware of my notebook computer that I work on had no problem with it. There was no malfunctioning of that Fujitsu Lifebook 732. Therefore, we will close this out and say that we know that Excel does make numerical errors and it is expected to. And from this point forward, when we're doing sensitive calculations, we're going to stay with Octave. So you're going to be seeing more of this program in the future.